5 earthquakes, 48 hours. Different countries, different oceans, different tectonic boundaries, and yet when you plot them on a map, they don't look random. They look like a sequence. That word, sequence, is the one that seismologists are careful about using publicly. Because the moment you say sequence, you're implying connection. And connection implies that what happened in one place influenced what happens next somewhere else. That is a statement with consequences. So scientists choose their words carefully, but the data doesn't choose its words carefully. The data just shows you what happened. And what happened in the last 48 hours across the Ring of Fire is something that senior seismologists are looking at very closely right now. I'm going to show you the 5 events, walk you through the science of how tectonic stress actually travels across plate boundaries, and explain why this particular pattern, this specific geometry of events, is the one that monitoring agencies have models built around. Because this isn't the first time the Ring of Fire has done something like this, and the times it has done something like this before are not reassuring precedents. Let's get into it. Before we get into the events themselves, I want to make sure you have the right mental model of what the Ring of Fire is, because the popular image of it as a simple circle of volcanoes around the Pacific massively undersells what it actually represents. The Ring of Fire is a 40,000-kilometer chain of subduction zones, spreading centers, transform faults, and volcanic arcs that encircles almost the entire Pacific Ocean. It accounts for roughly 90% of the world's earthquakes, and approximately 75% of all active volcanoes on the planet's surface. It is not a uniform structure, it is a complex, interconnected system of tectonic boundaries, where multiple plates are simultaneously colliding, diving beneath each other, and grinding laterally past one another. The key word in that description is interconnected. The Pacific Plate, the largest tectonic plate on Earth, is surrounded on nearly all sides by subduction zones. Its western edge dives beneath Japan, the Philippines, and the Mariana Islands. Its northern edge grinds against Alaska and the Aleutian chain. Its eastern edge subducts beneath South America along the Peru-Chile Trench. Its northeastern edge dives beneath the Pacific Northwest, along the Cascadia subduction zone, and at various points along its boundary, smaller plates, the Juan de Fuca, the Cocos, the Nazca, the Philippine, act as intermediaries, transferring stress between the major plates, in ways that are complex and not fully modeled. The reason this matters for what happened in the last 48 hours is this. When a major earthquake occurs, at one point on this system, it doesn't just release stress locally. It redistributes stress across the surrounding plate boundary. Sections of fault that were close to their failure threshold get nudged closer. Sections that were locked tight either get pushed further toward failure, or in some cases temporarily stabilized. The redistribution is real, it is measurable, and it propagates, not instantaneously, but over hours, days, and weeks across the connected boundary system, is called static stress transfer, and it is the mechanism that makes a sequence of earthquakes across widely separated locations not just possible, but in certain tectonic configurations, expected. Let me walk you through the 5 events in sequence because the order and the geography are both important. Event 1, Western Pacific, Tonga region. The sequence opened in the Tonga region, a subduction zone, where the Pacific Plate dives beneath the Australian Plate. At one point on this system, it doesn't just release stress locally, producing a series of significant events that have been building stress on the surrounding boundary segments. The event that opened this 48-hour window was not the largest of the 5, but its location matters. The Tonga subduction zone is one of the critical hinge points of the Western Pacific system, a place where stress from the Central Pacific propagates both northward toward Vanuatu, Fiji, and the Solomon Islands, and southward toward New Zealand and the Kermadec Trench. An energetic event here sends stress in multiple directions simultaneously. Event 2, Japan, deep crustal event. Within hours of the Tonga event, seismographs in Japan recorded a significant deep crustal earthquake. Beneath the Japanese archipelago, Japan sits at one of the most tectonically complex intersections on the entire Ring of Fire, the convergence point of 4 separate plates: the Pacific, the Philippine, the Eurasian, and the North American. Every major earthquake anywhere on the Western Pacific boundary changes the stress state at that intersection. The depth of this event is the detail that matters. Deep earthquakes, occurring below 70 kilometers, indicate stress being released in the subducting slab itself. Then shallow interface events. They can load adjacent shallow fault segments in ways that aren't immediately obvious from the surface geometry. Event 3, Alaska, Aleutian Arc. The third event occurred along the Aleutian Arc, the chain of volcanic islands that curves from Alaska toward the Kamchatka Peninsula of Russia. The Aleutian subduction zone is where the Pacific Plate dives beneath North America, and it is one of the most prolific earthquake producers on the planet. Major Aleutian events have historically preceded elevated seismic activity along the connected North American boundary segments, including the Cascadia subduction zone to the south. The Aleutian event in this sequence was shallow, occurring at the plate interface itself. Shallow interface earthquakes are the ones that produce tsunamis, and this event triggered monitoring alerts across the Pacific Basin before being downgraded as the wave measurements came in below warning thresholds. Event 4, Chile, South American subduction zone, on the opposite side of the Pacific. A significant event struck the Chilean subduction zone, where the Nazca Plate dives beneath South America. This is the same boundary that produced the 1960 Valdivia earthquake, still the largest instrumentally recorded earthquake in human history at magnitude 9.5. The Chilean boundary has been in an elevated stress state for months, with geodetic measurements showing accelerated interseismic coupling in sections of the fault that last ruptured decades ago. The event in this sequence struck a section of the boundary in the late stage of its interseismic cycle, meaning it has accumulated significant stress since its last major rupture, and is approaching the threshold where another large event becomes increasingly probable. Event 5, Philippines at the closing of the loop. The fifth event struck the Philippine fault system, a major strike-slip fault running the length of the Philippine archipelago, driven by the interaction between the Philippine plate and the Eurasian plate. This event completed a geographic pattern that traces almost the entire western arc of the Ring of Fire within a single 2-day period. 5 events, 4 separate tectonic boundaries, 3 different ocean basins, 1 48-hour window. Here's the part of this story that most coverage gets wrong, because most coverage overclaims or dismisses. The truth is more precise and more interesting than either extreme. Tectonic stress travels. That is not speculation. That is established, peer-reviewed, instrumentally verified geomechanics. The mechanism is called Coulomb stress transfer, named after the failure criterion, used to calculate when a fault segment will rupture. Every time a fault ruptures, in a major earthquake, it changes the stress state of the surrounding crust. Some areas become more stressed, pushed closer to failure, others are temporarily relieved. These stress changes are small, in absolute terms, often measured in fractions of a bar, but faults already close to their failure threshold don't need large perturbations to tip them over. A stress change of as little as 0.1 bar has been documented in published research, as sufficient to trigger earthquakes on critically stressed faults. The key variable is distance. Stress transfer is strongest in the near field, the region immediately surrounding the rupture. At distances of hundreds of kilometers, the static stress changes become very small, but the Ring of Fire is not hundreds of kilometers wide in most places. It is a narrow, continuous chain of connected boundary segments. Stress transferred from a major event on one segment travels efficiently along the boundary to adjacent segments. The 48-hour window is significant for another reason. Dynamic stress triggering, the passage of seismic waves, operates on timescales of minutes to hours. Static stress transfer operates on timescales of days to weeks. The fact that these 5 events occurred within 48 hours places them in a zone where both mechanisms could be operating simultaneously. What seismologists look for when assessing whether a sequence is connected is not just timing, it's geometry. Are the subsequent events occurring in locations that Coulomb stress modeling would predict as having received positive stress loading from the prior events? In this sequence, the answer for at least 3 of the 5 events is yes. The locations are consistent with the stress shadow projected forward from the prior events. That is not proof of causation. Seismology rarely deals in proof, but it is a pattern that is not consistent with random chance distribution of earthquakes across the Ring of Fire boundary. The reason this pattern matters is not just what it tells us about the last 48 hours, it's what historical sequences with similar geometry tell us about what tends to follow. There are several documented cases in the seismic record where rapid sequences of major earthquakes traversed large sections of the Ring of Fire boundary within compressed timeframes. The pattern is not unprecedented, and the historical record of what followed those sequences is instructive. The period between 2010 and 2012 produced one of the most remarkable sequences in the modern seismic record. The 2010 Chile M9.1, the 6th largest ever recorded, was followed 8 weeks later by the 2010 Mal aftershock sequence, extending northward along the South American boundary, 7 months after Chile. A major event struck New Zealand, 14 months after Chile. A major event struck New Zealand, 14 months after Chile. The 2011 Tōhoku earthquake, magnitude 9.1, struck Japan, generating the tsunami that caused the Fukushima nuclear disaster. Within 2 years, generating the tsunami that caused the Fukushima nuclear disaster. Within 2 years of the Chile event, major earthquakes had struck on 4 separate segments of the Ring of Fire, in a pattern consistent with sequential stress loading. I am not saying the current sequence is equivalent to 2010. I am saying the 2010 sequence started with a pattern that in its early stages looked similar to what we are seeing now. Rapid events across multiple boundary segments, stress redistribution across the connected system, segments that seismologists had identified as critically loaded being pushed toward their failure thresholds. The section of the ring of fire that carry the highest stress accumulation, the section with the longest elapsed time, is the Cascadia subduction zone, the fault system from Northern California to British Columbia. That last ruptured in a full margin event on January 26, 1700. That rupture produced a magnitude 9 earthquake and a tsunami that crossed the Pacific and struck Japan, with enough force to be recorded in historical documents. Cascadia has not ruptured since. That is 326 years of stress accumulation on a fault boundary that ruptures on average every 200 to 500 years. The current sequence has not loaded Cascadia directly, but the Aleutian event, the third in this sequence, sits at the northwestern corner of the North American plate boundary, directly connected to the same plate system that includes Cascadia to its southeast. The USGS, the Japan Meteorological Agency, Science in New Zealand, and other national monitoring agencies have all issued standard monitoring statements following the events in this sequence. Alert levels were assessed, tsunami warnings were evaluated, and in most cases downgraded as wave measurements came in below thresholds. The public-facing communications have been measured and professional. But read the technical seismology community's response to this sequence, the papers being posted to preprint servers, the threads in professional networks, the language in monitoring bulletins, and the tone is different. Seismologists are the language in monitoring bulletins, and the tone is different. Seismologists are is one that triggers professional attention not because any single event is unprecedented, but because the collective geometry of 5 events in 48 hours across this specific set of boundary segments is not a pattern that appears frequently in the instrumental record. When it has appeared before, the sequences did not end with the 5th event. Here is what I want you to take away. 5 earthquakes in 48 hours across the Ring of Fire is not by itself a catastrophe. The Ring of Fire produces major earthquakes constantly. What makes this sequence different is the geometry, the specific pattern of which boundary segments activated, in which order, within which time frame. That geometry is consistent with sequential stress transfer propagating across a connected plate boundary system. It is the pattern that Coulomb stress models predict as a high-risk configuration, and it is occurring against a backdrop of elevated global volcanic and seismic activity that has been building for months. The boundary segments that monitoring agencies currently assess as carrying the highest unrelieved stress, Cascadia, the southern Chilean gap, the northern Philippine fault, have not yet activated in this sequence. I'm not telling you that means they will. Most stress loading sequences dissipate without producing the major events that the stress models would theoretically predict. But I am telling you that the instruments are showing a pattern, and that pattern is the kind that makes seismologists check their monitoring feeds more frequently than usual. I'll be tracking every development in this sequence closely. If another significant event occurs on any of the boundary segments that received positive Coulomb stress loading from these 5 events, you need to see that update immediately. Subscribe and turn on notifications, because if this sequence continues, the next event is not going to be on a boundary segment that surprises anyone who has been watching the data. It's going to be exactly where the stress models said to look.